Okay, I think we're live. Hello everyone. Welcome to part 6 of the Trident build stream. Thanks for being here. Let's get started. We left off last time working on wiring, or underdeck wiring, and at the tool head. Sanity. Hey, Abraham. So, let me unplug this for now. So what I did off camera is I did a little bit of cleanup on the wiring, and I did some pre-flight checks just to make sure that we weren't going to get stalled on this stream today. So I didn't go to a point where I made it move at all. I didn't do any of the stepper buzz, any of that kind of stuff. So we'll be doing that live here. So I wanted to show you a little bit. If we can get in there, and maybe I can just try my other camera. A little bit of the tool head wiring. I ended up rotating the LGX stepper so the wires come out the other side, and then hiding the connector down here. As we all know, this cable cover is a little tight, but I worked with what I had. The probe connectors stuck right here, and I did run an Ethernet cable to the computer. We'll see how that changes anything. Can I get a quick confirmation, just because of the YouTube info? Okay, it just changed to excellent connection. It said no data for a bit there. So anyway, I got the tool head wiring cleaned up. I found out that because of the little extra piece at the end of some of these IGUS chains, this was moved far enough forward that when I moved to the max or min Y, the chain would hit at the frame. Now it clears it just the tiniest little bit by removing one link, and I think that's pretty much exactly what this distance here is. What did I do? So what else did I do? I ran the wire for the B stepper, but I haven't finished. I put just a holder insert in there to hold the wire. And I found out that I made a goof. So I was doing my sanity checks, and I was not getting a reading from the bed thermistor, and it turned out, and my camera already locked up. My second camera. I don't know what to do about this. Okay, anyway, let's switch back here. We'll just do this kind of thing. The microfits don't work too well if you use the same gender terminal on both ends. Oops. So I fixed that. I accidentally put female terminals in both ends, and had to swap the one side out for the male terminals. Prusa's AFS. Are you talking about their big farm system? I think it's really cool. I'm anxious to see it up close and more about it. I imagine a grid of computers like that, or printers like that, is a challenge for wire management and filament management. How are they gonna... Oh, they put the filament inside though, right? So I like my Prusa Mark III. I'm anxious to see what the Mark IV and the XL look like. Okay, so much of what we're going to do today and kind of finishing up wiring is under the deck, so I'm going to reposition my camera so you guys get a better view of the printer than of me. And hopefully this is adequate, because that second angle, I need to figure out a solution for that. Okay. So I added some little VHB taped and printed, zip tie anchors. Managed most of this. I still am going to change to a solution where I have a pigtail set up so I can swap controllers more readily and easily. It's this way. That's probably going to work out better. Shift these over a little bit. Okay, so power is done. The two, the part fan, the hot end fan, end stops, and based on Linneo's recommendation, I'm not using the probe for the probe. I'm using the I think it's not really labeled, but it's a fourth end stop here. All 8 of these on the Octopus are end stop ports. I get power from the probe, but I'm getting signal to the end stop. So I want to go through. The where I got the information for setting up the controller, what the pinouts are. So I'm going to switch over to the my shared screen, and starting, since this is an Octopus, I go to the Big Tree Tech GitHub, and they have, I'm going to scroll up here. If we go back to their, actually, let's go back to their main site. So if you go here and you try to find Octopus on the main page, they don't organize it to where you find it easily. So if you go to repositories, and this ends up getting sorted by last update. So depending on when it's updated, you may have to scroll, but at least you can find things. And Octopus has been updated recently, so it's at the top. And they have specifically for some information on how to set stuff up for Voron. So, and it says v2.4, but much of this and almost all of this is applicable to Trident. So they have some STLs here in the mainboard holder. I include all the mounts we need in the Trident folders, and those are what I'm using. I haven't even looked at what they've provided. But if we go to firmware here, they have more than just the firmware. They have a wiring diagram and jumper configuration. So I've installed the step sticks here, but we want to make sure that if you're using 2209s, that you remove all the ones in red and leave the green one. So it's the second one over from this orientation, the top 2 pins there. So I've done that on all of the 2209 spots. Now those are UART controlled. For the PT100 step sticks, those are SPI controlled. So I used another piece of their documentation to confirm what the jumper's set up for that. And it just so happens that you leave all the jumpers in for those, and it's set up for SPI, which would be the same as a TMC 2130. So you want to check those jumpers, remove the power jumpers. So it's not, and I'm not hooked up with the USB cable anyway, but it's not going to get power from USB. Check all of your fan voltages. So the bottom one here, as it's configured, is input voltage. In this case, it's 24 volt. The middle one is 12 volts, and then the top one is 5 volts. I have mine set up with the hot end fan at 24 volt, and my part cooling fan is at 12 volt. So I changed those to match. And then for the probe, I'm not using sensorless homing. So this number 2 here is all to enable the end stops for sensorless homing. I'm not using it, so all of those are empty. And then the probe, I've got set to 24 volts. This is 5, 12, and 24 again. Then I went somewhat by their wiring diagram here. I did my own stepper configuration, X and Y, and then I did Z, Z1, Z2, and then extruder, and then the last 2 I set up for the PT100 thermistors. Because this board has jumpers to set the the SPI output, or the, is that right? The diag output. You don't need to cut the pins on the step sticks. Sanity, SPI versus UART, which one is normally used, recommended? It's based on your step sticks. The 2209s use UART. 2208s do as well. I'm not sure the full range of which ones use what. I went by the recommendation for the print cooling fan and the hot end fan. I'm also we're gonna install the deck fans into these pins as well. I'm hoping that these will take the handle those 60 millimeter fans. I'm sure they will. I tried to find a spec to see if they had a max current on those, and I couldn't find it. So we're just going to go for it. Worst case, I can plug them into extra heater outputs later if I need to. We are going to use the bed output for the solid state relay like they do here as well. So things that are left today is we're going to install those two fans, wire the SSR, and then go in and configure the rest of it. I won't be using the EXP display outputs. I'll be using a touchscreen on this connected directly to the Pi, and we'll hopefully get to that today as well and configuring it. So this is kind of their Big Tree Tech's little handy Voron specific wiring diagram, which came in, it was helpful. I think they have, let's look at Clipper. So they have some information on how to use Clipper on the Octopus. I followed some of this, and I'll show you where I ran into problems. So they start giving you an output of the Raspberry Pi GPIO. I also went to just a Google search and found, we got 5 volts here, ground here, and then our 2 UART connections, which is how configured, how I connected the Pi to the Octopus, and this is the cable I made. So here they're talking about, if you read some of this, they're talking about how to wire it. 5 volt. This is the header here. It's here on the controller. It's a little 10-pin connector. The top 2 pins in this graphic are your 5 volts. The middle 6 are ground, and then the bottom 2 are transmit and receive. I found a spot, and if we see it, I'll point it out, but I found a spot that said that they internally swap the pins on the board, and I don't think that's actually true because I couldn't get it to work going straight TX to TX and RX to RX. I had to cross them over. So I made a little cable, and so I just made a little DuPont connector cable with, and these are not heat tolerant because I tried shrinking that shrink tube and melted the connector a little bit. So 5 volt power, ground, and then transmit and receive on the end, and then on the other end a 10-pin connector with, and I used 20 gauge wire for the power and ground, and then I just used some stepper wires, 24 gauge for the transmit and receive. So those go back on there, make sure they're in the right spot. Let me catch up on chat. Victor, how much linear movement precision is needed for a 3D printer? I'm not quite sure how to answer that. I don't quite understand the question or exactly how to answer it. Sorry. How do you remove the jumpers? No place to use a plier or something. I use tweezers. These tweezers work, or I've got another sharper pair. Every jumper has a little slot in the top that you can hook something small into to remove. Jaeger for the any kind of screen. I glance at it, see what percentage the print is into it. What I mean, I'll use it to do fine the Z offset adjustment as it's starting to print. If I want to do a quick home or something, lock the steppers or disable the steppers, that kind of stuff is handy to do on the printer. Otherwise, I do most of it in the web UI. Yeah, what Jeff said about the jumpers. So, okay. So I'm going to use UART to communicate between the Pi and the Octopus. I've got the wiring there. I'm kind of going through the documentation as it's provided by Big Tree Tech. Here is the wiring setup. It's a little confusing because I think they use more wires than you need. I'm not sure why. And here they actually, I believe they don't, or they do cross the colors here. So now we get into, they start talking about firmware stuff. But before we get there, we need to put something on the Pi, an operating system. I chose on this printer to go with Mainsail. I have the full distribution of Mainsail and Fluid on my printers. I honestly don't have a preference. I like some things about both. I dislike some things about both. But we're going to cover Mainsail here because that's what I used. I'm going to switch to another tab. Oops, not that one. That's the printer. Where did I put that? Here it is. Sorry. So Mainsail has a documentation site with very excellent documentation on how to install it. Getting started, where to download it. Mainsail OS is a ready-made image for the Pi. You download it. You use something like Balena Etcher or whatever to load it to an SD card. When you finish loading it, I always have to eject the card and put it back in for it to read, and then you edit the Wi-Fi supplicant file with your for your Wi-Fi information, and then you plug it into the Pi and boot it up. Your initial host name is mainsailos.local, and you can access the web interface that way. Before you do that, you should SSH into the, and let's see if we can do some of that. And I'm going to have to do some interesting typing here. Let's leave that up and just ignore my getting in the way of the, getting in the way of the camera. I'm using a laptop sitting here on a monitor stand. I'm going to move this over here. And I don't know how well that's going to be read, but oops, and I probably should have it on. Let's plug the whole thing in and turn it on. And give it a second. There we go. I had it on. I think I turned it off. So once that boots up, we'll be able to run this command again. Now I've already changed the host name, obviously. I have not done this on my laptop. I use my desktop to set this up. Here we go. Oops, sorry. Okay, so you log in SSH to the Pi. It's SSH and then Pi at and then the host name. If we go back to, so now we're in the Pi. This isn't going to be, and I'm sorry, this isn't intended to be a comprehensive tutorial on how to configure this. I'm kind of going through and trying to touch on things that caught me up, so hopefully it'll help one of you. So when you first log into the Pi, a good thing to do is to run sudo pi-config, and then this brings you into the and we're going to be back here because one thing that really caught me in configuring this we do in here, but you can go through and you can do things like go into system options, change your password, change the host name, change your, somewhere here, maybe it's the previous screen, you can change your time zone, that kind of stuff. Once that's done and you reboot, you can start doing your Clipper configuration. And the best place to go for your for the general Clipper setup is clipper3d.org and their documentation here. So installation, configuring, and then get all the way down into your first checks, making sure everything's working. So we'll be going through all of that. But if we go back to the Pi, the next thing you'll want to do is configure firmware for the controller. And you do that by going to the Clipper folder and make menu config. And this brings up this interface. And if we go back to the Bigtree Tech page, this is where this comes in. And they show you how to do this, and they provide bin files, but I wouldn't do that. I'd make your own. They provide the information you need on how you're configuring. If you're using USB, you set these options with the communication interface to USB. If you're using the UART, you set it to serial UART2, PD6, PD5, that kind of thing. If you set all these options and then save that and then make the file, so we can go back there. So all these options are set, and I had been playing around when I was troubleshooting this, and I tried the USB. So now if we escape and save and then just run the make command, it will generate the firmware. Then you can get into the Pi via something like WinSCP or whatever tool for your OS, and copy that bin file to the SD card for the controller to flash the firmware. Okay. Let's see where we're at. How's everyone? Not a whole lot going on in chat, so I'm either boring you to death or something. So now we're at a point where we have firmware on the controller, mainsail on the Pi. I'm not communicating with between the two yet. So setting up that UART connection. Now there's a few spots, and I had to put together information from a couple of spots. So here on Bigtree Tech site, they show you how to configure the firmware, and then if you go down here, there are a few changes you need to make down here. If you use the UART to communicate, now if you're using USB, you're pretty much done. Oh well, not really. You have to figure out what USB ID it is. But as far as configuration on the in the Pi, you're pretty much ready. if you look at the Clipper docs, you run the ls/dev/serial/by_id/star, and that'll give you your controller ID, assuming it sees it. If it sees it, then you enter that into your printer config. But if you're using UART, then you have to do a few other things. So if you go in, I found that the mainsail OS image for this already had some of this done, or maybe the documentation is out of date. But you SSH in and you remove these from the file in boot command line.txt. And that was not in boot command line.txt for me in the latest mainsail OS. So I didn't have to do this command, but I did have to add this dt overlay -pi mini urbt at the end of the file in boot config.txt. And all you do in your interface here is just go, and then I think this is the right way. And what was that file name? Config.txt. So sudo nano, and then scroll to the bottom and add that line. And then control, all these commands on the bottom, the caret is control. So you do control O to write it out, and it asks for what file name. If you just leave it, it'll just overwrite, and then control X to exit that. And then it tells you about modifying some the configuration in your printer config, adding your MCU. And just a second, sorry. But this isn't everything you have to do. It's missing a pretty critical step, and it's what hung me up. If we go back to their, I think there is a example firmware, and I think you have to leave the octopus part of this. Go to firmware and Clipper, and we look at the Clipper config. And somewhere, I think it's down here, setup for, this is some of the setup stuff, but this little part right here, use sudo raspberry config to disable the serial terminal. This is what caught me. So to do this, we go back to that Raspberry Pi config, sudo raspi-config, and we go down to interface options, and you choose the serial port. And I think, so let's make sure. So would you like a login shell to be accessible over serial? No. But do you want the serial port hardware to be enabled? Yes. Those are the two options. You choose no to the first one, and then yes to the next one. Sorry, Sanity. I told you I'm not a not a Linux guy. I'm just doing what I'm told. So those two options, you choose no to the first option, yes to the next one. That was critical in making this work for me. And I think I can just escape out of that. So in that mess of information, that's where I got to the point where I could communicate. Now, Jaeger, I checked that console. I did this disable serial port thing way late in the process. That the console thing wasn't in the config file before that. So I imagine that maybe the OS image had it removed. So while we're here, this default config is really handy because it gives you the default the port numbers. All these, so in a Clipper config, for each item in here, you're setting what port on the board to use. So for instance, for Stepper X, the step pin is PF13. You can get that from here, or they also have, and it's really a lot more difficult to read, But let me see if I can zoom in on this. They have a pins file, and let's zoom in here, and all that information is over here. So you see for driver 0, which is X, the enable pin is PF14, the step pin is PF13, direction is PF12, and we see all of that. Oops, sorry, down in here. So you could, their example config is useful, but really at least for me, being able to see where they're, like if you go down here to the heaters, like heater 0, the pin is PA2. Heater 1, the pin is PA3. So if we went down here to the extruder, you'll see is this where the heater pin PA2, and this should be, yep, right there, PA2. Okay, so we have the Pi configured, we have the controller firmware on, and now they're communicating with each other. We can go to the, let's try reconnect. So now we can see, and I've gotten this far enough along to where it's communicating, things are working, there's a configuration. But before you do that, you end up with just 3 options here. I think it's dashboard, console, and machine. You have to upload your printer config, and you can start a few different ways. If you go to the Trident GitHub, there is a example configs out there. There is not one for Octopus, but part of this, me putting an Octopus in here, is making sure that we have a good config that we can put out there. Sanity, I think a lot of them do. I mean, they should. It's a matter of where you find that information. I feel like Big Tree Tech has always done a really good job of offering pin layouts, at least for the boards I've used. They have some sort of diagram. The one for the Octopus, this guy is really tough to read unless you zoom in. But it's here, and all this information is in all these little tables. And so you say, this is one of the end stop boards, J32. So we come down here and we see J32, and it uses PG14 for its signal pin. So let's go back here. So now you download your example config, and in this case I had a config, so let's go. I used my config from my original Trident, and a lot of this information I hope is going to be useful, but I had set it up on mine because I was trying something different. I put all of my printer specific stuff in printer config. So there's some Pi stuff here because of setting up for resonance testing. But the basic printer information ends up here. And then I include a config just for the Octopus, and that's where all the pin stuff is. And we'll switch over to that and go through the different parts that you should be looking at. Then include mainsail. And then I wanted to see the temperature of the Raspberry Pi, so this little line here shows it on the main interface. And then things like the bed mesh and homing override all get defined in here. So I don't know if these are all correct, because it's a copy from my other printer, and I think I edited them. But you would change these based on your printer size. And then the homing override where it homes, which for instance here, this is a 300 build, I think. So we're going to set this. So this is where our end stop pin location is. So I'm not going to change this right now, but it's going to change. And it's very critical that we change that before we try to home Z. And in general, we're just going to change this right now to, this is the center of the bed. My other printer is a 300 build. So we're going to change this to the center of the bed for a 250 build. Now mine's not actually 250 in the Y, but that'll be close enough for right now. Then our Z tilt is what does the three stepper bed leveling, and the positions here should be in the example configs for all three sizes. They are slightly off right now, we're saying. So there is a pull request out there right now to correct them, and there's going to be a couple of changes before that gets merged. So this is the location of the pivot point for the three corners of the bed. So it's not the lead screw, it's where the GE5C, the spherical bearing is, or in my case, the IGUS spherical bearings. It's that point in relation to 0, 0 of the probe on the bed. And these were just extracted from CAD. And then there's some macros. I have macros for loading the filament and unloading it. And then there's some stuff that Clipper saves automatically on the bottom. So that's the printer specific parts of the config. And normally this would all be just mixed in or at the bottom of the of your printer config. I just have them split out. So we're gonna close this and we're gonna look at the MCU configuration. So based on what Big Tree Tech had mentioned, and let me find where that was. Right here for USB or UART, this MCU serial TTY AMA 0 is the UART port, and then restart method command are important. So that's where we put these. And then I start just going through and setting all of the pieces. So stepper X, that PF13, PF12, all those things you can get from this pin map. So for me though, if we look here, if you remember, I'm not using 20-tooth pulleys on X and Y, on A and B. Rotation distance for a 20-tooth pulley is 40, because one full rotation with a 2mm pitch belt on a 20-tooth pulley is 40, but I'm using 25, so this needs to change to 50. And I'm using 0.9 degree steppers, I believe. Yes. So it's 400 steps per rotation. And then I did not, oh yeah, so, and then the end stop pin. And the caret means there's a pull up. Exclamation point means invert it. So this will be useful later on the direction pins on if we need to change the way it homes. And then for stepper X, there's the 2209 settings for stepper X and just the run current and hold current. And I didn't set these. I don't know what they need to be for these steppers. This is what I use in the other Trident. So same thing for stepper Y. Stepper Z, the first stepper gets the end stop pin enabled or defined, and that's the micro switch end stop for nozzle height. And then the positions for in terms of build size are in here as well. The other two Z steppers don't get the end stop pin. You just don't define it. And then something in the interface here. There we go. Changes that all to black and white for some reason. So stepper Z2 and then the probe. So in my case, I'm using, let's go to the pinout. I'm using J33 for my probe, which J33 is PG11. And that's what I'm going to use for the inductive probe on this. So, and then for the afterburner Y offset 25, the rest of it's the same. These are just mostly copied from my other Trident settings. Extruder, same things. The extruder stepper direction pin will be important here. I'm not sure which direction that needs to run to extrude. Rotation distance, this will need to be changed. All of these are Bondtech settings right now. Or not Bondtech, yeah, they're the afterburner settings, but I'm running an LGX in here. So we should do a quick check. And maybe while I'm going through this, does anybody know what the settings for an LGX are supposed to be in here? If you can post them in chat, I'll copy them into here. Otherwise, we can do some searching. Pressure advance at 0.67. I have no idea why that is set so high. I'm going to set that to 0 right now. And then I'm not using a regular thermistor, so the sensor type here is the Max 31865 with the pin PD3 comes back to, I'm using, here, let's scroll up here first. I'm using motor 6 and motor 7 for my PT100 boards, and then getting the pin out PD3 from driver 7. And if we don't have the LGX settings by time, we'll go search for them. The SPI info for the PT100 setup. This is the same, just the SPI pins, and those, once again, you can get them from the pin out, and I keep losing that. And here they are: driver SPI, PA7, PA6, and PA5 for MISO, MISO, and clock or SCK. Oops. And there's the PA5, PA7, and PA6. And then I believe, so this RTD reference resistor value, this is left over because I have some, the PT100 sticks I have in the other printer were made by Ray, and he actually measured those. So that's why I had a value there. But I know Jared runs 401 on the, I think these are LDO sourced step sticks, so I'm just going to change that to that. Other things we want to worry about. So in Big Tree Tech's example config, they have the it has a built-in thermistor for MCU temperature. So that's what this does. Is it gives you on the mainsail interface the temperature. Rotation distance 200 times 16. Rotation distance is 8. What's the gear ratio on the LGX? Because rotation distance 8 seems really short, because that should be the okay, we'll look at it a little closer, maybe do some searching. Okay, so everything else, fan pins, once again we go back to that tab that I keep missing. Fan pins are down here. Fan 0, J58, fan 1, J59. Oh, I'm sorry, so those are the voltage selectors down here. PA8 for J50, J51, PE5. Those will all show up in here. PE5, PA8. And then I have some copied over settings for my Pi fan and the SKR fan, which will electrically hook up. So that's kind of the setup for the configuration. If anybody has any questions on that, and I just closed that without saving the couple of things I did, but we'll go back to it. Put in chat if you have any questions on what I covered. I know it's kind of a very high level overview, but maybe it'll help somebody. I think the extruder is a 1.8, Jaeger. I'm fairly certain it's a 1.8. Okay, so with all that set up, then we end up getting an interface. I mean, it should work. So the next step would be to go through and do all your checks, which we're going to put on pause for a second, and we're going to finish up some of the wiring, and probably put our skirts on, things like that, and then we'll come back and work on the basically pre-flight checks and see if we can make it move. Use 0.9 steppers with 25 tooth pulley. Yes, I am using 0.9 steppers with the 25 tooth pulleys. Okay, so I'm going to go back to shut this thing down. So I'm going to use the main cell interface to shut it down before I power it off. Give it a second. And unplug it. Get this out of the way. Okay, so I need to make a jumper wire to go to the SSR. Wow, that took 45 minutes already. Okay, so I'm gonna, let's go here. So I'm gonna go here, I'm gonna follow this path, come down to about here. And this doesn't need to be any special, it's just a signal wire. So this 24 gauge stuff will work just fine. Just going to match that. The only consideration here is getting something to crimp on the terminals. Okay, so those two wires, my strippers, I think we're going to go with these again, since I kind of figured them out. Try to find my, oh, here they are. If I have anything made for a little smaller gauge than that. Nope. Nope, these will work. These have those are really small. nice and tight. Let's go one at a time here. Okay, so I've got another board here. I was just using it to double check polarity on that because I think it's opposite of. So I could do that, or I could go over here to the here and bed out ground and positive. And does that match what I see? Yep. Okay. Put this. What do we got? Yeah. ESD be damned. So something I often do, and I didn't do it on this build for some reason, is I'll go through a board, and you guys can be annoyed again with me handling this, but I'll go through a board and I'll take a red Sharpie and I'll color the tops of the positive connections. I'll do it on the all over the place, but it ends up being nice later when doing stuff like this. I wouldn't have had to double check that. I would have already checked it and marked it. So that's gonna go like that. To grab a bunch of zip ties because we're going to need them. And carefully cut these. Okay. Now we're going to come over here, and we ended up with a little extra, which is good. So this is going to go right here. one. Just a little bit off of it. The SSR is wired in. I'm going to end up redoing this zip tie at some point, but it'll hold stuff in right now. Okay. Where are we at? Tag, rotation distance 55, gear ratio 45 to 14, third access. No, that's good. That's what I'm looking for, Jeff. Thank you. That'll be a great starting point, and that looks reasonable. The rotation distance, I mean, the BMGs are usually, I think, what, 22.6, and these are significantly larger diameter, so we'll give that a shot. Okay, so SSR is now wired in. Let's pull that back that way a little bit. Put that in right there. Place another zip tie. Okay, let's start putting some of the skirt pieces on so I can put the controller fan on. So I got all those printed over here. So I'm using the mod that I made back when I built my very first Voron, and I wasn't thrilled with the using the VHB tape to mount the fans. VHB is a good thing though, because it isolates vibrations from the printer, but I still like having the, oops, it goes this way, like having the screwed on mount. So we are going to get these set up. So I got fans, and I've got other pieces and parts. Accent pieces. So go through and set all of this up. You know, I like to use the mod that I made, so. So the STL for that is in Voron users. It's under STV PTRSN, my GitHub username. It has a couple options out there. But yeah, this isn't something that I would put in for official. At least I wouldn't. I think it's very solidly a mod. Okay, so these have recesses for these little mounts, and I just have to figure out which direction I had these for. Not there. I think that's right, like that. And we're going to put this here. So bear with me. Let me grab all the screws we're going to need. Yeah, the whole thing with the V0 printing all the parts is it'll print all the functional parts. Just gathering hardware. Which runs into, I mean, it creates some interesting limitations in general printer design. I think it's a good thing. I think it's a neat thing to be able to print all the bigger printers on the littlest one. But like for instance, there's kind of you saw, I think someone made the Trident style rear skirt to put the power connection on the side on a 2.4, but that's a really, really tight fit. If you try to it's a really tight fit to make that part fit on a V0 without requiring all the other mods that go along with it, like yeah, so when I was designing Trident, this power inlet, because this is a functional part, even though it's part of the skirts, the expectation is that this could print on V0, and it's 113 millimeters wide at its widest, so it does. It'll be interesting if any future designs challenge that. I have no anticipation of that happening, but just when it happens, what the decision will be made. So I'm just attaching the blank here. Yeah, Sanity, very high on the list was an easy upgrade path. We didn't want to make any more changes to the frame than absolutely necessary, and we really didn't want people to have to buy new extrusions. So having to cut, having to drill, that was okay, but we didn't want to have someone to have to go out and buy new extrusions. The other thing is, I mean, just the general aesthetic. We wanted to, like I said in the release stream, we wanted to make sure that it's symmetrical. Solutions that put 2 lead screws on one side and one on the other it wasn't necessarily forbidden, but it wasn't the desired path. So these are not all the same. Nope, not that one. There we go. Getting all the text messages. Okay. So now I gotta figure out what route I want the wires to come out. We'll just go right there. reach all the way over if I do that? That'll probably reach close enough. Awesome. Okay. So what length screws did I need for this? I think they're 25 millimeter. Yeah. Thanks, Jaeger. I'm glad you enjoyed it. A Trident would be difficult because the extrusions aren't long enough. That'd be a huge change. And none of these screws that I'm putting in should be very tight. It's just snug. Oops. Should have reamed these holes out a little bit and they'd slide through. Yeah, fasteners at Misumi are very, very expensive. Okay, so one assembly is done. I think I'm going to have enough. I might change the pin that I use because all of these, I think at least most of these, 6 of these are PWM, and 2 of them I think are full input voltage. So M5 T-nut. It's a well-fitting one. I pushed it past. There we go. And then oh, I grabbed an 8mm screw. That's why it wasn't working. Okay, that is not centered yet, but we'll center it up here in a second. That's going to go there. Three. Oh. Maybe I'll put these T-nuts in before I mount that. There we go. Oops. There we go. Well, these T-nuts are behaving very well. It's the easiest way for these things to multiply is just having just a couple of spares. And suddenly you've got a whole plans for a whole new printer. Long. Now I can move this one into place. Just about perfect. What do we got? Just aligning all the gaps. Everything is designed for about 1 millimeter in between, but that in actuality ends up being a little more because of the part shrinkage. Okay, so I don't have to redo an end on this. I'm just gonna, I think this will fit the very, let's look at the pinout. So let's go over here, and these are our fans. Okay, so this is, let's see, let's let YouTube catch up and see what you guys are seeing. Okay, perfect. So J56 and 57 are down here. These are the input voltage fans. They're not PWMable. So J55, the third one over, is the first one with an output pin. So that's the one I want to use for here because it's the closest, and I think I can still reach it on the plug. So I'm just gonna plug it in right here. And that is a tight fit, but for what I'm doing right now, we're just gonna leave it. And then making sure the jumper underneath it is set to 24 volts. All of them are set except for the one 12 volt fan I have. So they're all 24, so we're just gonna leave that right there. And then, even though I just put this one in, I'm gonna replace that zip tie. The side skirt piece, it depends on this build size on whether it has one or two. 250 only has one for those pieces. That's a great point, Jeff. We actually discovered the silkscreen errors on the pre-release Octopus boards. So let's double check that. I know it worked. I've already tested the fans and they work. So based on that, it looks okay. But we can look at this. We've got towards the edge of the board, according to this, is the negative. So that's correct. But it's a good thing to keep checking. Okay, so this side is on. Rinse and repeat. So this is going to go like that. And I actually put my fans on both sides, blowing inwards on both of them, just across the stuff, and just figure out with the bottom panel on, just air movement is more important than anything. So and I am going to four. I'm going to ream these real quick just so they're a little easier to put together this time. This is just I bought a metric reaming bit set off of Amazon. It wasn't very expensive and it has come in very handy. I printed a little, this is the 5mm one, I printed a little thing so it's easier to grab and just do by hand, because most of this plastic stuff I'm just doing by hand. But I'll let my fingers get tore up a little bit doing this quickly since I don't have a thing on that. One. Hopefully this will save a little bit of time. Okay. Now, where were we? So if that goes there, that's getting the fan. Where did my other fan go? There it is. Do something like that. That's just going to do something like that. Aha, yes. What a difference. Okay. So the way these goes, I need a little, because the accent pieces stick through, so I use an M5 washer on these just to make sure that the nut on the back side will hold the accent piece in place. Bye-bye. And the last corner one here is just decorative. Okay. Oop. Make sure my wire's going in the right spot. Make sure nothing else is pinched. It's going to go up through the middle of the slot, but that's okay. And I'll just install this one right next to the other one, and we'll change our configuration to match. I bought like I don't know how big a bag of these zip ties, but I go through them like crazy. Okay. That's looking good. That. There. Side skirts are on. Where are we at? When doing pressure advances, it's normal to find the compromise between the one side of a corner turning inwards and the other side bulging out. I'm not sure. Does the SSR need active cooling? I wouldn't recommend mounting them with a plastic printed piece. This is the metal bracket that we use in the DIN rail. It provides some level of heat sinking, but I haven't had a problem, and I don't think we're running these at their max rating Okay. Oh, heat sinks for the steppers. I've got those around here somewhere. Here they are. Just a little bit of. Make sure my fingerprints, for the most part, are off of them. For my upcoming plans and streams, I'm going to start messing around and playing with different setups as far as camera setups and angles. I know this hasn't been absolutely ideal. I'm hoping that it's given a good view of what I'm working on, but I may switch to something that gives a little more overall view and then try to figure out better solutions for the other angles. As long as people enjoy seeing what I'm working on, I'll keep doing this. I think it's fun. I said coming up is some legacy work and some switchwire work. Okay. What am I missing? Yeah, this little Logitech webcam I have is giving me nothing but trouble, and I don't know exactly what the problem is, if it's the camera or the computer. Okay, I think I can move this to the back and just put the rear skirts on. I'm not going to be actually, so this is the little keystone jack holder. I think. Which way does this go? Yeah, it goes like that. Something like that. I don't have any to put in here, so I'm just putting the blanks in. Well, this is because the Omron data sheet rates the max current without a heatsink at 3 amps. Does the metal DIN rail mount count as a heatsink? That's a good question. I don't know, but as far as I know, I haven't had a problem. But I don't want to tell you that it's just fine and dandy without knowing for sure. Oh, that's a front one I grabbed. Rear one. My wife's digital SLR recently stopped working, so maybe a good opportunity to add to the capabilities. What else do we got there? The cat's asleep on my chair right now. We don't run any of the heaters at full power either. Berserkadunk. Oh, okay. I ran out of M3 T-nuts. We are almost at the point of doing our first moves. So I usually get up at about 5, and when I don't, that's when the cat decides to let the whole house know that I'm not up by sitting in the middle of our kitchen and meowing. Okay, oops, we got the front. Okay, so the front skirts, I push this one in, and it depends on how your print settings are, how these little accents push in. But I pushed that one in. We can push another one in. If these are a super loose fit, it doesn't matter because they get held against the steppers. The steppers hold them in. The front Z steppers. Waiting for someone to make those light up or be a button or something. You're absolutely right, Jeff. I honestly forgot. See what I'm gonna do about that. I can always put them in. I can put them in after. That one quite lined up. Yeah, these are pretty easy to deal with, those after everything's assembled. So that's what I'm gonna do. Okay. Let's see what we got here. Ta-da! Looks like a 7-year-old without his front teeth. So what I want to do probably is do all the config checks next. And then see how much time we have beyond that, because I really want to make it print. So we don't need a display to print. We might do a wrap-up stream for panels and display and all that kind of stuff, because I think it's important to make it print today. What do you guys think? And now I'm jinxing myself because something major is going to go cattywampus. But we're about an hour and 40 minutes in right now. Okay, let's plug it in. Got way too long of a power cord here. Okay. Tweak the let's go with that. Power it on. I don't know, at some point I think this is going to get high voltage set up for the drivers, so we'll see what it can do with these big steppers and all that good stuff. So I'm going to move this out. Just kind of slowly move this around. I'm going to move the bed down out of the way. Just for first checks. Okay, let's go over here And let's go to reconnect. There we are. So the very first thing I want to check, and I'm not necessarily going to go in any order, although a good idea is to come over here to the Clipper site and go for config checks. And they have all the verifying temperature, verifying heaters, end stops. Well, let's just go through this. This is basically what I'd be doing. First thing I want to do though is get the end stops going. So in mainsail, and I know there's a spot in fluid, I just don't know, probably the similar spot, but we got a machine, and if we scroll down, we can refresh our end stop status and see that they're all open right now, including the probe. So I can just go through them and just manually push the Z end stop, and it's triggered. Let's push the X end stop, and the Z end stop is open and the X is triggered. Reach around and get the Y. Y end stop's triggered. Grab a piece of metal. Uh-oh. Okay, well, I got that. Just any piece of metal. Let's grab this guy. Big honking piece of metal. And put it under the probe. And triggered. Awesome. Let's tune and end stops. That's good to know. Let me fix my... I've got something jammed in my drawer. Too many tools in there. There we go. Okay, so those all worked. What if it didn't? We would go into our, in my case, so your printer config. And when I say printer config, I'm going to go into the board config here. And let's say, for instance, our X, if it was our X end stop, if it was triggered and it should have been open, you would, I think that goes on the other side. Add an exclamation point to reverse it, right? Save and restart. And if we came down here, and now see X is triggered, and when it's pressed, it's open. So we don't want that, but that's just kind of one of those things. If it was not expected behavior, we'll delete that. Save and restart. Thank you, 69 Pendolo. I will remember. In fact, I should probably do that before I make it move, because those will turn on when I make it move. Sanity, on your let me see if I can show this. Those Prusa lead screws, I think, are fine if you use I think are fine if you use the MGN12 setup, but I would make a spacer to lower the front ones. And yeah, all the end stops are wired and normally closed. I know I'm bouncing around here, but let's go and change those fan pins, because that's a good idea and I'm going to forget otherwise. So we're going to go into my controller configuration, and I have an SKR fan, which is the controller fan, which turns on whenever there's movement, when the steppers are active. And I had this set for PD12, but we're going to go back here, and now I got to throw it on its side real quick and remember which one I plugged in. So, controller fan, I'm going into 54, which is PD14. And Pi fan, I'm going to do PD15. Oh, bump. Okay, so back to the configuration. PD14 for the controller fan, and PD for the Pi fan, PD15. We're going to save and restart. It is still in place. And it moves fine. I haven't turned anything upside down. It's always been sideways. It is a little short though. I grabbed it from something else and I never got around to cutting something, so I think it'll trigger before I hit the bed. We'll find out. Okay. Yeah. So is that the Pi side? Yep, the Pi fan is running, which I want it to be running all the time. It just runs slow. And the controller fan is not. Okay, so let's go back here. So let's do a stepper buzz test. So let's go down because I want to home this and get my Z end stop position. Yeah, mine's pretty much the same, Jaeger. I think it's right at 1 millimeter below the top of the magnet back here. Everything moves freely. So we verified the end stop. So let's do the stepper buzz. So we're going to copy this command here. We're going to go to our interface and we're going to go to the console, so maybe we can see this a little better. And we're going to buzz stepper X. And it's moving. I don't know if you can see it. I don't know if it's moving in the right direction yet. But we're going to repeat that command for Y. And it's moving as well. Yeah, I knew what you meant, Jaeger. It's just my spring steel sheet doesn't reach the back of the bed, so to the magnet is the same equivalent as what yours is. Okay, so that moved. So now let's try Z. And that should be this guy. And the first movement, if it's correct, should be up. And it's going down. What? Is it down? First movement should be down? In any case, if it's not down, let's see if they're all the same. So first movement on this one was down. So stepper 1, yeah, I think you're right. I think it should go down first. So the rear is moving as well, and first movement was down. And then when that one's finished, yep, they're all moving down. So they're all moving in the same direction. I think that's correct, but we'll find out when we try. But if they weren't, then you could go back to your pins configuration for the Z steppers, and let's just take this one, this direction pin, the exclamation point there. You would remove that if you wanted to go the opposite. So that is correct. So now what I want to do is I want to go back to the, I guess let's find out if our extruder is moving at all. Let's go back to the console. And then we're going to go, I think it's just extruder. Yep. And I think it's backwards based on the first movement. I am using the LDO 300 millimeter, but with the 4 millimeter lead Z steppers. So let's go back. Okay, so all steppers are moving. I think the extruder is backwards. So let's go in there and change that. So let's go to the extruder and the direction pin. We're going to get rid of the exclamation point. Save and restart. Now I'm going to put the tool head in the middle, and I'm going to be ready with my finger on the X end stop, and also ready to hit emergency stop, but I'm going to home X. And that went back. Completely not what I wanted. So X on home goes towards the back, and Y on home goes to the left. So there's a handy, and I'm gonna have to bring this up. Where are those? Where can I get to those? There's a chart, and I should have remembered to download it and look at it. Let's go here. Just because now I'm in unexplored territory in what I am opening. So give me a minute and I'll bring up, I know on the Discord, there are pins in the different build channels. And let's just go to, because it's probably good to go through where show you how to get to some of these resources. And bear with me, I've got this up on another screen. There is a pin. There it is. And I'm just bringing up the V2 one because it doesn't really matter. There, perfect. Okay, so this, oh, is that the V2 one or is that the, oh, it's the Voron 1. That's fine, it's the same thing. We went back on X and left on Y. So back on X and left on Y means the steppers are swapped. So we swapped the A and B connectors. So let's go back to our interface and shut down, because we can't do this with it powered on. I'll give it a second. And I lost the music. Where are we at? Let me catch up on chat real quick. Okay, so let's power this thing off. I think technically Torx Fighter, the afterburner, is asymmetrical as well, by just the tiniest little bit. Okay, let's see what is going to be. Let's move this to the back so it doesn't fall. Yep. So we are, let's see if the, we are just going to swap X and Y. Okay. Plug it back in. Yep, so just swap the plugs between X and Y. I'll let it power up. It'll be fixed, Torx. That will be fixed. Let's see if we've got a connection. Yep. So here we are. We are going to slowly move the tool head back to the middle. And once again, I'm going to put my finger on X. Okay, so X is going back, and Y is now going to the right. X is going back, Y is going to the right, means stepper A is inverted. So let's go back to our configuration. Stepper A is plugged into, that's the terminal, oh, stepper A. But which plug is that one plugged into? Because it ends up getting, anyway, we'll try it. We are going to go to machine and here, and it's either, I think it's Y, just from previous experience, but let's find out. Direction pin. Let's put an exclamation there to invert it, and save and restart. Let's go be ready. Home X. I'm just going to let it go since it was moving in the right direction. And home Y. Woohoo! We have X and Y homing. Awesome. Now let's make sure Z is going and be ready on the end stop. Nope. So what do we got? Move out of range. Oh, because I have, okay. Let's do this. It's because my configuration still has the safe homing, the homing configuration for my 300 build. So let's go to the machine, and this is in printer config because that's where I have the homing overrides, and this is going to be about, let's see, this should be about 253, 256. What is the max? Oh, we got to set that on the other. And this is going to be, and I'm just making some guesses here. I'm going to change this back to, because I don't have a full, what is my, yeah, 240. So that'd be 120. And 25. These are the things that I didn't save last time. Okay. Those X and Y locations need to be set. I'm going to move this up a bit manually just so I get a better eye on it. Dashboard. Home X. Home Y. Let's see if this goes out of range now. Move out of range. What is that actual... I know where the problem is. It's the actual movement range should be, let's just for fun. Yeah, that was about right. Let's go here. Our X and Y. I've got 252. And this needs to be something like 256. Y should be fine. What do we have? Titanium screws sound expensive and sound kind of unnecessary, but might look cool. Let's go back here. I just want to make sure things are moving in the right direction. I'm not actually going to home Z. We're not ready to home Z. I just want to make sure. Oh, did I do that again? Yeah, that's my fault. I'm fumbling. Let's go back to printer config, because I had this at X, Y, and Z. What am I doing wrong? Move out of range. Well, it's trying to go to 135, 254, which is really arbitrary right now, but the max X is 256. That's greater than 254, so it should be able to get to there. Oh, you're absolutely right. That was a big brain fart. That is absolutely right. So X should be 250. That's, yeah. My bad. About. You're absolutely right. Now it is functioning correctly, and then it's going to go to somewhere. Okay. The other thing I don't think I did, and that's why it's in a weird spot, is if we go back to machine And the config, I left Y at 40 rotation distance. That needs to change to 50. Oh, and all these happened before. Okay. That all because I closed it without saving last time. So let's go through and sanity check everything. So let's assume all the pins are correct because everything is moving in the right direction and end stops are working. But we got 16 microsteps, rotation distance of 50 for X and Y, 0.9 steppers, so 400. My position end stop for X should be about 250. We'll fine tune that later. Position end stop for Y, same thing, about 256. We'll leave it there and then hit 0, 0 and see where we fall, and then we can adjust that from there based on what clearances we have. Stepper Z's, so rotation distance is 4, so these are 2 start, 2 millimeter pitch, which means a 4 millimeter lead. Are we back? Okay. I don't know. It is a little warm in here, and I forgot to turn my fan on, so give me a second. Hopefully that doesn't create too much background noise. Just get a quick confirmation if folks can hear me. Now that'll take a second. We have music and okay, awesome. Okay, so back to rotation distance. What we were talking about before. We go down to on extruders. What is they had a example here for what the using a gear ratio. Comma. Okay, that's all I really needed to know is what the syntax was. Comma. And then what was that? Someone wrote it out for me in chat. 3717. And then we have a rotation distance. Oh, 34, so this is Galileo's, what was on here before. But someone said 55. Okay, so microstep 16, rotation distance 55, it's a 1.8 degree stepper, so 200 steps per millimeter. All the temperature stuff should be working. The heater stuff, so let's call that good and save and restart. Here, let's take a little tiny break. And bring the turd up here. Look, Charlie, it's almost done. Look at all this hair. Yep. Get cat hair in every print. I think I don't ship anything out. I haven't received anything from DFH, but I don't know if I can compete with this thing. I don't know how much of that is showing up on camera, but it's terrible. Whew. Yeah, he's a good cat. Oh, there we go. Cat hair reinforced filament. Okay. Now that I'm covered and everything's covered, let's get back to it. Holy moly. Let's see. Let's blow it over there. I think the clicky probes, Wyatt, are really interesting. I just haven't tried to install one yet and go through all the macro fun. It'll be something I look at. It could be maybe a topic for another stream, installing one of those and configuring it. Okay, where are we at? We just went through and did some checking on the configuration. We are now going to Home X. Those are loud, but I haven't changed any of the stepper currents or anything. And now we want to find the position of that end stop. But first I want to do a go through the range of motion. So let's go back to the console and let's go G0X0Y0. And really I want to do like 10, just so I don't And then let's go 0. Oh, let's let you know what I'm actually doing here. So we are at 0, 0. It'd be nice to, I mean, I could move this up with the printer. Just kind of seeing where we're at in terms of the actual build plate. It looks about right. And now if we go G0, oops, 0x250, Powell, these are big 0.9 LDO steppers. They're 60 millimeter steppers. Oh, sorry for getting my head in the way. That looks right where we want it to be. So now, as far as everything is about where I want it to be. As far as range of motion, hitting the edges of the bed, being on the front edge of the bed, even though we'll never really print, or at least we'll want to avoid the holes on this Prusa sheet. So now we are going to find the position of our end stop. So I'm going to move this even further up. And we're going to home X, home Y. Yeah, that is atrociously loud. I just want this to be close enough so I can eyeball it better. So now we're going to make a guess. G0X135. Okay, let's go 145. That is almost dead on. Well, I wouldn't say dead on, but it would hit right there. Yeah, 146. And right where it's at right now is so 146, 256 would hit the pin. So let's go for it. So now we go to our machine and go to our config, and we're going to go right here on the end stop position, 46, 256. Save and restart. And a little crooked here. Home all. I'm on the power. Making sure. Nope. So my pin is not long enough. So I crashed it a little bit there because my pin is not long enough. Let me see what I can do to fix that. I was hoping I should have tested that. Let me see what I have for other slightly longer pins. A nice, really short one here. Same length. Oh, there's a couple that might be longer. rob Peter to pay Paul. I have for... There we go. I just stole it out of the green V2. And that's about a millimeter over the... Okay, so I crashed this thing, which probably wasn't the greatest idea, but everything's still good. Let's try it again. Ugh, that is loud. Woohoo! Now, let's... Yeah, thanks, Sanity. Let's see, what can I do? I've got extra long pins. I'm gonna put, it's too long, but you're right, it will keep me from crashing there. Now that's safe. Okay, now what I want to know is at what point, so I think I should be able to move the bed up, and I want to know that the probe triggers before the nozzle hits the bed. So I'm just moving this up close, and then I'm going to go over to the machine and query the end stops, and the probe is triggered. So that gives me some confidence that when I run a Z-tilt function on this, that it's not going to crash the head. So let's give it a try. I think we've done all of our checks. Everything's moving in the right direction, even if it's a little loud right now. Okay, and then let's do a Z-tilt. Oh, well, that's wrong. Okay. I crashed it. And I know why. I'm missing things. I'm shortcutting it by grabbing the configuration for my other Trident, and that's causing me to miss some important checks that we should go through. So let's go over here and let's go to, do we need this? We probably want that one. Let's go here. So let's go to the Voron Trident GitHub. Yeah, my probe points are off, even though the Z-tilt locations should be correct. Let's go in here to one of the configurations. Yeah, I just need to change the probe points, and I'm just going to take what's out here. So I'm scrolling through the one of the configs that's out on the GitHub right now. Where did we throw that stuff? So I down here in the Z tilt. So with a 250 point, the points here. So I have the Z positions. So Z positions are the locations of the spherical bearings. The points are what are probably wrong. So let's look at this. Let's go to the machine and go to the printer config. And down here, so it's trying to hit 245 with the nozzle. I think this is the point on the nozzle, right? So this should be 195. So it's going 50 millimeters over. Let's just copy this whole thing. This is the 250 build for the points. And this is just me not going through, trying to shortcut it. But that's good. Hopefully it's a learning point. Let's see, the rest of them, yeah. So the last point would have crashed too. So everything else looks sane. My positions do look different because the ones that are out there, these should be more accurate than what's out there. We're going to update what's out there. It didn't seem to cause any real little divot in my magnet, but not too bad. That's home again. Oh, and I haven't greased the lead screws either. Once we get this all homing, I'm going to do that. So now Z-tilt. Be ready. There we go. There we go. Woohoo. Let's see how we're doing on, oops. Let's go over here. Oh, and I'm in the way. It was 2.4 millimeters off the last time. What did it say there? 0.08 this time. So it should... some of this probably. Oh. 0.0075, and that's what my tolerance is set to. So what I'm going to do now is just put a little bit of I just have super lube here, some sort of grease on these, and then I'll run the yeah, the squeak, I noticed that's... I don't want to put too much here. And hopefully running it the full length will distribute it well enough. I'm trying to get it down into the grooves and not sitting on the outside of the lead screw. What's going on? Are the points still shifted to negative X a bit? I'm not sure. Probably the camera angle. Oh yeah, this will attract all the cat hair. Okay, so now we're gonna go to, and I'm just gonna go to the console, and I'm just gonna send a G0Z200. I get a little bit of squealing there to start, but should get some grease in there. Oh yeah. All the cat hairs. All the squeaks are gone there though. Let's put just a little bit up here. And let's go. Let's see. I think we should have full 250 millimeters of travel, so let's ease up on it. No, we're gonna hit like 248. I wonder where that is. I do have taller standoffs on here than what would normally be, and why did I do that? Because I was trying something else. So I think I can hit like 248. Nope, like 247. Okay, why is that? Oh, I haven't set my Z offset. So this is, yeah. That would be why. So now let's go G0Z5. No more squeaks is good. Seems to be moving smooth. Cool. I'm gonna run that down one more time. 0Z 245. 245. Extra grease off of there at the top. Okay. Oh, yeah, absolutely, Jeff. It'll get redone. Nicholas, yeah, this is a 250 build. Okay. Let's check the heaters. So, probably should have touched the bed at some point to make sure I didn't have a default on. Let's go to the pinout, and I've got the bed running on PA1. So let's go to our configuration and make sure that we're gonna go to heater bed PE1. Is that what I said? No, PA1. What is PE1? What? So I'm glad I checked that. So heater bed. Oh, heater pin. Oh, sensor pin. Sorry. That's right. PA1. Okay. And then the PA2 should be the hot end. So let's check that. Extruder, heater pin, PA2. Okay. So let's just set some both reading. Oh, that's the other thing I did that's different. Let's go here real quick. I had changed the sense resistor on one of them, but not the other one. same. That's part of that didn't save it last time thing. Oh. I stopped it at the very end of travel, so it's going to bottom out on the first move. So I'm just moving it up by hand a little bit. I've got grease on my hands. Hey Nicholas, I think the rat rig's a cool machine, but I haven't built one. I have no idea. Okay, let's go back to our Clipper documentation and continue on with our config checks. So now I want to do the temperature stuff. So we're going to make sure that we're getting, first just the basic idea is we're getting temperature readings from both thermistor setups. We are now going to do, this is verify heaters. Yeah, that's what I figured. Let's just throw in a target temperature and just run. Oh, fan comes on as it should. And 50C isn't going to burn you. See if it's getting warm. It is. It's warm, not hot. And then let's do the same for bed. Let's see at what point it... Yep, it's warm. So both of them are functioning. Thanks, Daniel. Now I'm going to cool them down. We're going to run PID tune on both. Which I'll have to do again, I think, once I get the whole thing enclosed. But we're trying to get to the point where we're printing. Get something printed. They are, Daniel. If you go and search for STV PTRSN on the Voron users GitHub, you'll find my mods there. Okay, so let's go back to now we're going to, we did all this, we're going to do a PID tune. So let's copy for the extruder, add a target, we're going to go to the console, and here, and I'm going to change this to 215. So I'm going to PID calibrate it first to a PLA temp, and then I'll redo it later. With that there, we should see the target temperatures and everything change, and then we let that run. So I am probably going to use this blue PLA. What can we work on to get ready for trying to print something? We need to, because I think the idea is we're going to do one more stream buttoning this up. Display, other things. And by the end of that stream, it'll be fully done, able to print ABS, and probably do an ABS print on that one. So I'm just going to look at a way to rig this up. Got my spool holder. We'll bolt that to the side. That's a good question. What should we print? Should it be as boring as a Voron cube, or what do we do here? This is doing that. Why don't we turn this? Since I've got plenty of. How's that doing? Okay, it's going through its cycle. Put the spool holder on. I'll try to rig up the rear panel. Yeah, I think this will work. Putting a fitting with lots. Holy moly! That was cat hair. I don't know if you saw that, but it was a whole tuft of cat hair that went flying. Oh, let me. This needs a couple of heat set inserts. How is that? That's still running. Let's move this over here. Iron accessible. Looks like okay, so the PID tune saved. So let's save config. Let it save and restart. And let's go back to here and get the bed. Copy, paste, and I'm gonna go, yeah, 60's fine. We're doing PLA first. Now it's gonna run the bed. set inserts in the exhaust housing. That'll work. What do we have? M500. Depends on the DC bed, Sanity. I know the Prusa one on the switch wire doesn't take long at all. Jared, I did. I am very pleased with the Revo, and I can't wait to get a production one. It is really cool to be able to swap the nozzle so quickly, and on every other one of my printers, it's a very rare occasion for me to swap a tool head to get a different nozzle size, and there's no excuse not to on the Revo. It's so easy to change, and it cools down so quick to be able to get in there and undo it. Yeah. That's my 0.8 nozzle. Came in the little end mill container that people are talking about. Okay, we're gonna do some more setting up of this while we're waiting for that. Mounts. I'm not going to put any filter media in this. There was a ticket that suggested the change of this from a single center screw to on the side. It's kind of one of those no duh moments. Should have done it, but it has been, it does sit in there so much nicer. Okay. Can I actually do this without the back panel? I don't know if I can. Maybe we'll just let the filament fly off the spool through a Bowden tube, but yeah, I think I'll abandon the exhaust idea. Okay. That finished. So save config. It's warm but not too hot, so it seems reasonable for 60C. Shift this thing around again. Oh, that's what we can do. Let's at least use this to kind of control the filament a bit. hit it all. I think this will work really well, what I'm about to do, so. Just gonna set that guy in there. The whole bench is just a little tall, but just like that. And like that. And we can hit all the spots. I have not used any filament sensors. I do, when I'm close on a spool, I'll weigh it. For my coils, I use these eSun spools with a printed adapter, and then I weigh this whole thing before I put the filament on it. That way I can tell how much is left at any point. Otherwise, I just weigh an empty spool of the same brand for other stuff. That's not the snap together spool, that's the bolt together spool. Let's see what we got here. Yep, it moves in. What are we going to print? I'll just be boring and do a Voron cube. Let me grab another paper towel, a clean one. Good call, Jeff. We need to do the offset. Okay. Good call. What would I do without you guys here? Let's set some reasonable temperature here and 60. Let those get up to temperature. See where we're at. So those are configuration checks. And stop calibrate. Use a piece of paper here. This local real estate company is very kind to constantly drop these little pads, little notepads on my porch. And they've been doing it for years, so I have a pile of them. and they're super handy because it's not a full sheet of paper, but it's regular paper, and it's just nice and easy to use for this kind of thing. Go ahead and home the whole thing. And while it's doing that, I'm gonna slice I'll just slice a Voron cube on the other computer and send it over here real quick. Okay. We'll print something fun in ABS next round. These are 2 amp steppers. Let's go in here and bump those currents up. 0.9 seems reasonable. Let's just see if it makes any effect. Make a change. Let's see what it does. We're going to interrupt our preheating, but that's okay. We'll start it right back up. We also probably should look at our extruder currents because this is an LGX. Oh, okay, so this is set for the that would have been fun. I think 5. They don't want you to go over 0.7 because that was set for a Galileo before. Let's go back to 180. Oops. And 60. And then I got a file here ready to go. I don't know why there it is. Z-tilt. Sitting here, let's confirm. Just bump the extruder up a little bit and confirm that we're moving in moving in the right direction and get a just extrude. Skipping somewhere. It's not. It's catching somewhere. Let's check a couple of things. Did we... I have a PTFE tube in there, right? Okay, so that pulls out. I should be able to push that all the way in. Let's see. Let's pull this out and see if I can feed it. Feed it straight in. There it is. And then put some tension on it. Now I should be able to extrude. There we are. Plastic extruding. I usually do 180 for ABS. I figure I should probably do 160 for PLA. Okay, so we're going to set the Z offset. It's been warming up for a bit. It's not going to be perfect, but it'll be good for a test. We still have folks there. Just running a Z-tilt real quick. Oh no, I sigh all the time. I'm fine. I'm thinking of different things, things to do, things that I should try to do in this stream versus hold off to next stream. Thank you though. I appreciate it. home again, and we're going to run Z end stop calibrate. Paste that in there, and now we're going to do, what is it? You run paper test. Isn't it test ZZ equals minus something? I think so. Test ZZ equals minus, I can go at least -5 on this one. Okay. So now let's just narrow in on that. -1. Okay, now let's get our piece of paper in here. -0.5. Oh. That's just slightly over, so we're going to go 0.2. Okay. -0.1. Where are we at? There. That's there or a little tight. But I'll call it. And then what is it? Accept. And then save config. Go back to keep the thing preheated. Now what am I forgetting? Am I good? I got Z end stop calibrated. I've got filament in it. I've got a file slice to hopefully work. I just grabbed some settings off the other computer that I used when I was testing PLA on the first Trident. Do we have anything in? I mean, it's a PLA print. It should go fine. Let's give it a go. Do we still have anybody listening? Oh, we have peak right now. No, it's not all good. It's probably terrible. Rotation distance is not configured. It's probably a good idea to sanity check that before we go further. We can probably do it. Yeah, I cleaned the plate, and I'll do baby stepping on the console if I need to. But the extrusion, I'm kind of going off the assumption that the numbers we put in the firmware are close, but that's probably not a good idea. So why don't we do that? And with the hot end and everything in place, it's just a matter of running the filament through really slow, marking it and running it through slow. So let's go ahead and do that. So what I would do is remove this and just cut off some of this. small one. Let's get a reference point. And we can at least get some this at something I can actually reach. 140. Let's heat up the hot end. This is E-Sun. I'm gonna go 210. Let's move the plate down a bit out of the way. So let that plate really get to 60. Let's just do that twice. See how close we are. One more time. It's right on. I mean, it's within. It could be calibrated. Let's be real. It could be calibrated, but I measured that at 140 millimeters, and it's at like 40.5. So. Extruder idler is screwed in correctly. Well, it's a LGX, so it has this little tension lever. So we extruder idler. Yeah, I think everything is good. I think we should. Tension, pull the filament. I think we're good to go. That was a good suggestion though, but I'm glad the settings you guys looked up were correct. So let's let this cool down just a little bit, and then we'll just start to send it. Control the ooze. I don't, Powell. I don't use a start print macro. I tend to home and on the V2s run a QGL, and then my my start print is just a home and move to the corner to 0 basically and start print. So let's see. Oops. Now we're going to Z-tilt. Just oh, because the bed temp, I set it, I didn't change my profile to 60 degrees, so it's got to wait till it hits 65, I guess. Which means we'll get a little bit of nozzle ooze, but that's okay. Printer's definitely going burr. Need to figure that out. Might just be these steppers. It might, I mean, it is just resonating. Printing. Let's see where we're at. We are not getting not sure what it's doing. It's moving, but it doesn't seem to be actually pushing anything. It's not actually extruding. I'm not quite sure why. The LGX is moving. Do I not have enough tension on the... I'm going to stop this in a second, but I want to get a better idea of what's going on. Okay, I think it was just me not knowing the LGX tensioning. So let's pause this and cancel it. Because it started, once I put tension on the lever, it started extruding. So I think it was just me. And let's go ahead and preheat that to 65. Now I don't want to touch this, so I'm just going to kind of scrape this off. That little bit, it could be a little closer to the bed. So yeah, I thought it was pushed over, Kennedy, but I'm just getting used to this particular extruder. I think we're just gonna go for it, resend it. Yeah, everything else should be okay. Let's just... Handy dandy flashlights, pen light. I actually haven't set up a mesh on my 300 build Trident yet because I haven't had to. It prints fine without a mesh. I don't know if I'll need one here, but I'm printing in the center of the bed, and for this print I'm sure it'll be fine. There we go. Plastic's coming out. That looks reasonable, first layer so far. Yeah, I mean, as much as PLA hardly smells, there is a cat hair in the middle of the print. It's embedded in the first layer now. That looks like a pretty reasonable first layer, at least for what I can see. Holy crap. I sped it up. I forgot. I left the print settings on my other printer ABS profile. It's fine. How bad is the noise on the through the camera? Is it overwhelming? Okay, as long as you can hear me, I'll... Oh, I shoved the printer into the... There we go. I think we're at 100 millimeter per second perimeters and 120 or 50 infill. Let me see. I can check. Looks like we're at 100 perimeters, 80 on the external perimeters, 120 on the infill, 100 on the solid infill, and a few of the other things are at slower speeds, but... And the fan kicked in. Thanks for coming, Jaeger. It was nice to chat with you. So we are going to have another stream in the Trident series, and that'll be wrapping up things like the display. We're going to build the... I'm using a Waveshare 4.3 inch display. It'll connect with the DSI cable to the Pi, and we'll configure and set that up. We will put the panels on it, put the exhaust on it, route the PTFE tube properly. Basically everything, kind of wrapping anything else up, anything I can think of. If I find out anything on stepper settings or whatever in between, we'll cover those. I'm going to try to keep generally with this time frame for the streams, but if I can figure it out, I'd like to sneak in a couple more, because there's some projects I really want to get done, but I really want to share them, especially the legacy and the switchwire stuff. I want to get those up and running, so those could be potential material for some midweek streams. But yeah, this thing is loud. It's louder than my other Trident, but it's completely different setup with these steppers and everything. Derek, I'm using a mount that I grabbed out of user mods. This is the mount. It goes in. It's kind of hard to see, but it sticks out just a little bit. But the person who designed this did a good job of keeping with the aesthetic. I tweaked it a little bit because that's what I do. But overall, it's basically what he put out there. I think I can give you a little better idea. It'll sit about like that. So I think I have probably some pressure advance in the profile, but no resonant testing. No input shaper configuration on this. That's something we can do in the next stream too. All that kind of fun stuff. But I'm excited to get this thing printing. Yeah, it definitely could use some tuning. But different steppers, these 60mm LDOs, 25 tooth pulleys instead of the 40 tooth. I'm glad I put the foam tape where I did. I'd get some extra noises, I'm sure. It'll be interesting what it sounds like with all the panels on, too. See the octopus when you're done printing. So Clemex boy, you want to see like the wiring setup and everything as it's completed, because I can take a good picture and post them on the Discord. I'll do that because I don't think I'm gonna keep the stream going until this finishes this print. I mean, it's going pretty good right now. 15 more minutes, but I don't know if we want to sit here listening to this for 15 more minutes. print is looking really good though. Take a picture of it too when it's done. Post it. For the level of tuning you saw me do, which is 0, it's looking pretty decent. Ooh, my stomach growling. I don't know if the second camera is even... Doesn't seem to be working. Yeah, I don't know what's going on with that. I gotta figure this stuff out. It's frustrating me, and there's some things that point to it could be my computer or OBS, and some things that point to maybe the cameras. Okay. Well, given that this is, like I said, this is going to be another 15 or more minutes until it's done. Maybe more. Maybe I was looking at it wrong. It's saying 45 minutes. So I'm going to cut the stream here. Thanks again, everybody, for coming in. I'm pleased. We have some regulars in here that I'm glad to see. The new people I'm really glad to see. I hope this is good. Good content, even watching some of the fumbles. And I'm going to keep doing it as long as I have some people that are interested in it. So have a good rest of your weekend, and I will post some pictures on the Discord when this is done, and I'll talk to you next time.